Yes, we are dealing with the chapter known as atoms. Part 2 have been completed in the last class. In the last video, we have completed distance of closest approach and impact parameter. Now, we are going to derive the expression for energy of an electron in hydrogen atom in terms of radius using Rutherford atomic model. Okay. So, to derive this expression, let us consider a nucleus or a hydrogen atom with a nucleus charged plus Ze and one orbit, because hydrogen consists only one orbit and one electron which is revolving in this orbit. So E with that electron which is revolving in a circular orbit and it is moving with the velocity v, and let r be the radius of this circular orbit. Then from this diagram, from figure, we can write plus Ze as a charge of a nucleus. Charge of nucleus. And what is V? Velocity of the electron. Velocity of an electron. Correct? Then what is E? Electron in the orbit. What is M? Mass of electron. Mass of electron. And R with the radius of this orbit. That is radius of orbit. We know that this electron is revolving in the circular orbit, correct? Then because of its motion in a circular orbit, it possesses the kinetic energy, and this electron is at a certain distance from the nucleus, therefore it also possesses potential energy. That we have written here. What is that? The electron possesses kinetic energy due to orbital motion and potential energy due to presence of the charge on the nucleus. Now for stable atom, that is the aim of this chapter, right? We have to understand why the atom is said to be stable, right? For a stable atom, the total energy of the electron which is revolving in a circular orbit must be equal to sum of kinetic energy and potential energy. I will consider this as equation number 1. For a stable orbit, if orbit is said to be stable, if centripetal force is equal to electrostatic force between the nucleus and electron, right? That centripetal force is given by what? mv square upon r. And what is the electrostatic force between nucleus and electron? That is 1 by 4 pi epsilon naught q1 into q2 upon r square. In place of q1 and q2, plus Ze and E are there. That's why plus Ze into E upon r square. I will call this equation as 2. Now for this equation number 2, divide by 2 on both sides of this equation. That is mv square upon 2r and into Ze square upon 4 pi epsilon naught into r square into divided by 2. Now here r and r can be cancelled. So here the remaining equation is half mv square LHS, and the RHS what happens? Ze square 8 pi epsilon naught r, because we are multiplying this 2 with the 4. Therefore, what is the equation for half mv square? Kinetic energy equal to half mv square. Therefore, in place of this, whatever half mv square is there, I can write kinetic energy. Therefore, kinetic energy equation becomes Ze square 8 pi epsilon naught r. I call the equation number 3. Next, similarly, potential energy. What is potential energy? Potential energy is given by the equation 1 by 4 pi epsilon q1 into q2 upon r. Right? Here q1, q2 what? Plus Ze is a q1 and minus E is a q2. Why we have to consider here minus? Because potential energy is a scalar quantity, not a vector quantity. For a scalar quantity, we have to consider its polarity. Hence, I am considering here negative. Therefore, the final equation for potential energy is what? Potential energy is equal to minus Ze square divided by 4 pi epsilon naught r. Then I will call this equation number 4. Now we got kinetic energy and potential energy, which we required here, kinetic energy and potential energy. Now both we substitute in this equation number 1 such that total energy is equal to kinetic energy. What is kinetic energy? Kinetic energy is here. That is Ze square upon 8 pi epsilon naught r. That is Ze square upon 8 pi epsilon naught r plus what is potential energy? Minus of Ze square. Therefore minus Ze square upon 4 pi epsilon naught r. Now what is what happens to the equation? Total energy equation will calculate. So the total energy becomes what now? E is equal to Z square upon 8 pi epsilon naught R plus into minus Z square upon 4 pi epsilon naught R. So here I can take common Z square upon 4 pi epsilon naught R. So what is remaining here? So remaining here, if Z square upon 4 pi epsilon naught taken common means here 1 by 2 will remain. Here this whole term have been taken outside, that is minus 1. Now what is final answer for this one? Z square upon 4 pi epsilon naught half minus 1. So then it will become minus half. Therefore the equation, total energy equation becomes Z square, here minus I will take outside, 2 into 4, 8. Here 8 pi epsilon naught R. So this is the energy of electron in hydrogen atom in terms of radius. So here it is required radius. Right? This is the radius. So here we can write where Z is the what atomic number, E with the electron, epsilon naught with the absolute permittivity, and R is the radius of the orbit. We can calculate. Yes, after calculating the energy of a electron in a hydrogen atom in terms of radius, we'll go towards move towards the merits of Rutherford atomic model. What are the merits of Rutherford atomic model? The first one, it could explain the large angle of alpha particle scattering. So he explained why exactly they are deviating, deflecting large angles, alpha particles. That is, we have understood or learned in the experiment. Rutherford experiment, we have studied that. Second one, it explains about size of the nucleus and atom. Using alpha scattering particle, we come to know the size of the nucleus and size of the atom. That we have know that the size of the nucleus is 10 raised to minus 15 meter and the size of the atom is about 10 raised to minus 10 meter. That could be understood by the Rutherford atomic model. Demerits. The demerits are it could not explain the stability of the atom. But we used the equation stable orbit and something, right? But here it could not explain the stability of atom properly. Why? We have some explanation for that. According to Rutherford, what he is telling, whenever the electron revolve around the nucleus, see here, this is the nucleus and this is orbit, correct? And when the electron revolving in the orbit, correct? What it does? It radiates the energy. What it does? It radiates the energy. If it is radiating energy, according to quantum theory, anything which is losing the energy or radiating energy, it collapses or it comes down, because when it emits the energy, it will come from higher energy level to the lower energy level. For example, if we consider more number of orbits are there, if any electron which is revolving in a higher orbit, if it loses energy, it comes to the lower orbit. Again, if it is losing the energy, again it will come to the lower orbit. Finally, when after losing its complete energy, then it becomes, where it goes, losing energy, and it collapses with the nucleus. If one electron collapses, then there is a deficient of electron. At that time we cannot say that the atom is stable, because it lost one electron. That's why we say that this could not explain the, which one? Rutherford atomic model could not explain the stability of the atom properly. Second one, it could not explain the origin of spectral line. Whenever these electrons jumping from higher energy orbit to the lower energy orbit, they radiate energy. During that, spectral lines produces. But exactly how it produces, he could not explain Rutherford. That is the drawback of or demerits of Rutherford atomic model. So I am completing this part 3 video atoms part 3 here only. Part 4 will be continued in the next class. Thank you.